How transformer works by Dias of physics. Let's see the main parts of the transformer. There you can see the primary coil and the secondary coil. Two coils are there and is connected by the iron core. Keep in mind, the primary coil is a conductor, iron core is a conductor, secondary coil is a conductor, but the connection between the primary coil is not to the secondary coil by the conduction. So this is insulating coil and this also insulated coil, and it links, not the physically link, but linked by the function. So the transformer is an energy transferring device. Here the current in the primary coil, and there will be voltage and the results current in the secondary coil. It's not conduct through the soft iron core, it's energy transferring. Energy transfer electrically into magnetic energy, then again energy transfer electrically in the secondary coil. Now when we look at the working principle of the transformer, as we know that the three parts, primary coil, iron core and the secondary coil, we can see the importance of having two coils. The two coils for step up or step down voltage. Step up or step down voltage. So when the current in the primary coil produce magnetic field, with the current in the primary coil produce magnetic field, as the current in the primary coil is alternating, the change the produce the magnetic field by the primary coil is changed through the secondary coil. Now it passed through the secondary coil, and as it is AC current, alternating current, the field direction also changes. What is the result? The field lines interact, or we can say field lines cut by the secondary coil, causing voltage to induce in the secondary coil. So what the core do? The function of the iron core is to strengthen the magnetic field. And the importance of AC power supply here is very crucial, because of the AC supply only the magnetic field produced by the current is change its direction due to the change in current. If not, the transformer will not work. Now these are some useful relationships. This is the voltage ratio. Voltage ratio is equal to the turns ratio. P stand for primary and S stand for secondary. That is, primary means input, output. Input voltage over output voltage is equal number of turns in the input coil or the primary coil over number of turns in the secondary coil or the output coil. And also the power in is equal to the power out, power into the primary coil and power out from the secondary coil. We assume that it is 100% efficient, or sometimes we call that as ideal transformer. Ideal transformers are 100% efficient, power in equal power out. Now as we know that power is equal voltage into current, so primary voltage into primary current is equal secondary voltage into secondary current. So this is with out, this is with power in. Now let's take this example. Step up transformer has 3300 turns. Step up transformer of the primary coil has 3300 turns. So this is this 3300 turns. And question is how many turns required here. And what the input given is step up voltage, then step up. So you have to understand step up means voltage increasing. So it is understood that this is input voltage or primary voltage and this is output voltage. So primary voltage, you can see that here you can see here that is 15 and here 340. As this is a ratio, no problem of substituting with kV, kilovolt here and kilovolt there, because it's cancelling out. So what is the answer? When you simplify this, you get the answer as NS will be 75,000. You can work out and see. Number of turns in the secondary coil will be 75,000. So once you get the answer, you can recheck as it is step up. The secondary coil number of turns have to be greater. Now, as we know that step up and step down transformers, from the structure you can see that primary coils is less than the secondary coil in step up. Step down, primary coil turns greater than the secondary coil number of turns. So now these transformers, where do they use? Now step up and step down, step up near the power station and step down near the household. Right? Two type of transformers used in the power transmission. Now step up transformer increase the voltage. This goes to increase the voltage, and step down is to decrease the voltage. So near the power station, step up transformer increase the voltage. And what happened once you see this step up here, VP IP, that relationship VS IS. So step up transformer reduce when it going up. This reduce the transmission current. It is very important because low current means it's less heat dissipate in the transmission. But when it go to the end user, that is in the household level, it require low voltage for safety. Otherwise, in transmission current is less but the voltage is high, but the end user need low voltage for safety. So here another idea that is given to you, as I said in the beginning, the core, primary coil core and the secondary coil all are conductors, but you can see that when the primary coil has the current causing field lines move through the core, which is a conductor, so which results induced voltage in the core. So soft iron core is a conductor, that is the reason. And as a conductor it has electrons, so electrons will experience a force, so electrons move. So what is current? Charge over time. So electrons are moving with time, so we can say that it passed a current through it.